My name is Abby Percich, and the title of my research presentation is Plutonium Isotopes as Tracers of Sediment in an Urbanizing Landscape. Excessive watershed erosion affects water quality, aquatic ecosystem health, and the economic profitability of agricultural lands by removing valuable topsoil. Sediment fingerprinting is a modeling method which uses physical and chemical properties to distinguish the sources of suspended fluvial sediment. The basic determination of fluvial sediment is between surface and subsurface sources. A tracer is a physical or biogeochemical property of sediment that is used to track sediment transport and find potential sources of fluvial sediment. Plutonium isotopes are an emerging tracer used for sediment fingerprinting due to their long half-lives. Plutonium-239 has a half-life of 24,110 years, and plutonium-240 has a half-life of 6,561 years. The objective of this study was to test the viability of plutonium isotopes as sediment tracers by looking at 5 watersheds undergoing various degrees of urbanization in Johnson County, Kansas. The various degrees of urbanization can be shown on the study site. Kill Creek is 16.7% urbanized, Blue River is 20.8% urbanized, Cedar Creek is 24.4%, Mill Creek is 67.4%, and Indian Creek is 98.3%. We collected weekly time-integrated stream sediment samples over the course of a year using tube traps. We collected samples from 6 possible sources, including stream bank, grassland, woodland, cropland, construction, and residential sediment. Source sample locations are also shown on the study site illustration. All samples were analyzed for plutonium activity using inductively coupled plasma mass spectrometry, ICP-MS. Our samples were sent to and analyzed by Dr. Michael Ketterer, an innovator of the ICP-MS technology at Northern Arizona University. When the results of that analysis were completed and returned, a Bayesian n-member mixing model and mass balance equations were applied to the data to separate transported sediment to its 2 sources, upland surface erosion and subsurface stream bank erosion. The conceptual model illustrates some of the major findings and results of the study. Results from plutonium tracing indicated different plutonium activities in surface and subsurface sources. Plutonium activity was generally higher in agricultural watersheds when compared to urban watersheds. Our unmixing model also showed dominant stream bank contributions in all watersheds. A major finding of this study was that sources of sediment in agricultural watersheds depend on storm intensity, whereas in urban watersheds, they do not. During small storms, the dominant source of fluvial sediment in agricultural watersheds is upland sediment. As discharge increases, source dominance shifts from upland to in-stream bank sediment. However, in urban watersheds, stream bank sediment is always the dominant source, potentially due to impervious surfaces increasing fluvial shear. In conclusion, plutonium isotopes were successfully applied and showed that most of the fluvial sediment in these watersheds is sourced from stream banks. These results also highlight the efficacy of plutonium isotopes as sediment tracers and show how land use and hydrology affect the sources of sediment.